So I'm Jenni Evans. I'm a professor in the Department of Meteorology and Atmospheric Science. I'm a faculty associate in the EMS Earth and Environmental Systems Institute, and I'm also the director of Penn State's Institute for Computational and Data Sciences, or ICDS. So when I was a kid, I really loved maths. I was a bit of a maths geek. I was also someone who got into a lot of mischief, but maths was fun. And so as I grew older, I kept doing maths, and I went to university and I majored in maths, and I didn't know what I wanted to do, except I did not want to be a maths teacher. And so I was looking for something. When I was a little girl, also Tropical Cyclone Tracy, which is a hurricane in Australia, came on land and destroyed most of the city of Darwin in North Australia. And as a little kid, I saw this, and that cyclone destroyed the city at Christmas time. So thinking as a little kid about all of those other kids stuck in my mind. So I found out in my second year at university that I could use maths to study the atmosphere and to learn about weather and climate. And that just really took my fancy. So after that, I took all the maths courses I could that helped me to advance my career in that way. And then eventually, I worked in mechanical engineering labs straight out of my undergrad, just trying to figure out what I wanted to do. I worked in another lab in the maths department, trying to figure out what I wanted to do. I backpacked around Europe, trying to figure out what I wanted to do. Then I ended up in graduate school studying tropical cyclones. What I want to show you today is just a video of Hurricane Ingrid coming ashore in North Australia. And I'm just going to skip ahead a bit and show you these are two young weather observers doing something that is not recommended, which is being outside as a hurricane is coming by. But they got some fantastic video of this storm. So if you look at what's coming, they're going to swing around, and you're going to see a building break up and fly by. So there it goes. That's a building. That was a building. Now you'll see they're going to throw just a can into the wind to give you a sense of the wind. And there it goes. And if you can see it, it just disappeared. So this, and there's a young meteorologist getting excited about a weather event. When you look at the aftermath, there's no leaves on the trees. One of the things they told me is, other than the chainsaws, it's so quiet. There are no birds, no animals around. So it's an amazing experience. So as someone who's focused for most of my research career on tropical cyclones, which are also called hurricanes, I was really excited to be able to fly into Hurricane Ivan in 2004. Ivan was moving up the Gulf of Mexico, headed towards the Florida-Alabama border, and it was a Cat 4. Ivan had been a Category 5 for most of its life, off and on, as it came from the West African coast all the way over and into the Gulf of Mexico, and it was in a very intense storm, and it was headed for Florida. So I went and flew 2 different days in the NOAA Hurricane Hunter aircrafts. And so this is a picture of me taking off in the NOAA P3 and flying into Hurricane Ivan. The funny thing about this one was that we came out to take off and they were having trouble getting the plane started. So they had to wheel out this big thing and essentially jump start the plane. Now, I figured I was safe because the pilots and all the scientists who usually do this were intending to come home for dinner. So I went along and it worked out, and I got to fly right through the eye of a hurricane. This is a great big old plane, and it's not set up for passengers. You can see that long view of inside the cabin. You can see one of the guys holding onto a bar that grab bar is there because if you're walking around doing research, you're not sitting there with someone saying you must stay in your seat and watch for the light. But when you hit turbulence, like when you're going through the eye, your feet can go out from under you because it happens so suddenly. So you grab that bar and you work your way back to your seat and you sit down and you put your seatbelt on. So this is me sitting in my seat tracking a radio sonde that we've dropped out of the plane to understand what's happening immediately below us in the atmosphere and when it hits the ocean surface. And so this was one of the most fantastic experiences of my career to that point. So I was looking out the window of the plane and I decided I wanted to get a picture of the eye wall. And what I was trying to show here is that the eye wall of the hurricane, that ring of thunderstorms immediately around the center where the winds are the most intense, the eye wall slopes outward with height. And that's something we call the stadium effect. And so I thought immediately of Beaver Stadium when I saw that hurricane eye wall. And again, being able to look out and see that was amazing. And all the other observations we took that day that gave me a lot of insight into what was happening in that storm and helped me to really get a visceral sense of the hurricanes that I use computer models to study all of the time. So if you want to learn something about a hurricane at home, one easy experiment you can do is to get a really big bucket of water, or at least get a bucket of water and only half fill it, because you're going to stir it up. And then stir as hard as you can and get the water going round and round and round as hard as you can. And look and see what the water does. And you'll see that the water piles up near the edge of the bucket and it goes way down in the middle. And we call hurricanes low pressure systems. And you've just made a low pressure system in a bucket. There's less water in the middle, so there's a low height in the water and more water outside, which is the rest of the atmosphere.